Let's do another example of a integration by parts question where the derivative does not terminate. So we can start off by highlighting the first term as e to the x, and we can highlight the second term as cos 2x. All right, so in our derivative integral table here, we can set this up like all the other problems by putting e to the x for our derivative and cos 2x, which was our second term, as the integral. Okay, so when we take the derivative of e to the x, you'll notice that it keeps on continuing. So you'll see that it actually never terminates. So this is one of those, this is an indicator that this is a different style of problem where we need to use some different techniques to finish off the problem. Okay, so when do you know when to stop your derivative column? Well, that means you have to take a look at your integral column here. I have cos 2x, and you want to keep on taking the antiderivative until cos 2x appears again in the cycle. So the antiderivative of cos 2x is going to be 1/2 sine 2x. And the antiderivative of 1/2 sine 2x is going to be -1/4 cos 2x. And you'll see that the cos 2x here and the cos 2x there match up, and it doesn't really matter if there's a coefficient of -1/4. So you can stop there. And that means I can get rid of this e to the x over here. Okay, after you do that, we can set up another column here on the left-hand side for the signs. So this is going to be positive, this is going to be negative, and this is going to be positive. Okay, and then just like the previous problems, we can start highlighting the rows here. So plus e to the x times 1/2 sine 2x, and then we have negative e to the x times -1/4 cos 2x. And then just remember, we also have to look at the very last row because this is a problem where the derivative does not terminate, so that means we have one extra step to kind of consider at the very end. Okay, let's take a look at our first row here in blue. I have basically e to the x, and I multiply that with a 1/2 sine 2x. Let's write that over here. That's e to the x times 1/2 sine 2x. So that's my first row there. Okay, so I'm going to delete this. Erase this now. And then let's take a look at the green row. So there's a minus sign and a minus sign. So that's going to give me a plus e to the x times by 1/4 cos 2x. All right, and after that, I can erase this. And finally, the last thing that I need to do is I need to take a look at this entire horizontal row here, and I need to write that as an integral for my very last step here. Okay, so I have a positive sign and a minus sign. So positive times a negative is going to be negative. And then I need an integral sign. And I have e to the x, and that's going to be multiplied with 1/4 cos 2x. So the 1/4 I'll put in front, so 1/4, and then cos 2x, and then I need to have a dx sign to finish off. All right, so when the derivative column never terminates, you actually need to have one more term at the very end, and that has to be written as an integral, and that integral is going to be a product of your last horizontal row there. Okay, so after you do that, let me just erase all this. I guess I'm done with the columns here. And once you've used up your column there, you want to make this equal to the original question here. And the original question is the integral of e to the x times cos 2x dx. Okay, and you'll notice now that this integral right here should match up with this last integral right here in terms of the in terms of the integral and the terms. You'll notice that if this is e to the x, you have e to the x over here. If this is cos 2x, you have a cos 2x over here. So it should match up so that you can combine like terms. So now the next strategy here now is I want to take this integral and move it over there. So this is going to be the integral of e to the x times cos 2x dx. So now you're treating this like a linear equation now, where you're bringing something from the right-hand side to the left-hand side. If this is going to be a minus sign, then if I bring it over, it should be a positive sign. So positive, the integral of 1/4, or 1/4 integral e to the x cos 2x. dx equals to all of this stuff here in green. So that's going to be e dx bracket 1/2 sine 2x plus e dx bracket 1/4 cos 2x. Okay, so we're almost done here. Now I need to just combine like terms on the left hand side here. So there's a 1/4 here, and there's also like an invisible like 1 over here, right? So I need to combine these two integrals here. So 1 plus 1/4 is going to be 5/4. So 1 plus 1/4 is 5/4, and that's going to be the integral of e dx times cos 2x dx equals to all of this now, which is e dx bracket 1/2 sine 2x plus e dx bracket 1/4 cos 2x. Okay, just the last few steps here. We just need to get rid of the coefficients here. So 5/4, if I want to get rid of it, I can multiply the right hand side by a 4. That gets rid of this 4 here. And then the last thing is, how do I get rid of this 5? Well, I divide this whole thing by 5. And then I'm going to have the plus c to finish off. If you want, you could also take this 4 and multiply it right through. So 4 times 1/2 is going to be 2. So that's going to be 2 e dx times sine 2x. And then this 4 can also multiply with this 1/4 here. Erase that there. So 4 times 1/4 is going to be 1. So that's going to be plus e dx bracket cos 2x all over 5 plus c. So if you want to take that last step there and simplify your work, you can. You don't have to, but it does make your answer look a lot nicer. Okay, so that's it for this particular video. I just want to go over one more example of a question where you have to use some different strategies to finish off these integration by parts questions, especially when your derivative column doesn't terminate. So there's a few extra steps with those kind of style of problems. All right.